Now, in this particular part, we're going to learn about homogeneous equation and non-homogeneous equation. So for AS physics, you need to understand what we mean by homogeneous equation, whereby homogeneous equation are those equations with all the terms have same SI base units. Yeah, so, and what is the purpose? You need to ask yourself, what is the purpose of learning whether an equation is homogeneous or equation non-homogeneous? So this case determines if the equation is correct. It helps to determine if the equation is correct. Yeah, because for a formula to be correct, for an equation to be correct, it must pass one condition, in that it must be homogeneous. So if the equation is homogeneous, is not a confirmation, yeah, that that formula or that equation is correct. You need to move to the next step of determining whether that equation is correct by doing an experiment to confirm if it's correct. That is basically, we're talking about the equation or the formula. To determine if it's correct, you have to do an experiment. You have to do an experiment. Yeah, so you need to carry out an experiment in the lab in order to determine whether that equation is basically correct. But one of the conditions for a formula to be correct is basically using confirming or checking if it's homogeneous. For instance, if we say V is equals to U plus AT, this is an equation you can be able to check whether that is true, whether it's homogeneous or not. For instance, here we can be able to say the unit for speed, velocity, this is final velocity, this is initial velocity, this is acceleration, and this time. So for you to check whether the equation is homogeneous, you are going to write this equation as you write the base V in terms of it, base SI unit, and that's going to be meter per second, and this one also is going to be meter per second, right? But acceleration, we know this is going to be meter per second square multiplied to second, because the unit for time is seconds. So you can see here that this one of this S second is going to cancel with this. We end up having meter per second plus meter per second. Now, since the SI base unit for all the terms are the same, we can conclude and say this equation may be correct. The equation may be correct because all the terms, they have the same SI base unit. Then, for instance, if you make a mistake and this checks non-homogeneous, we can say is an equation non-homogeneous is an equation in which the terms do not have same base SI what? Unit. So if you confirm that an equation is not having the same base SI units, then it means that the equation, this confirms equation is wrong. For instance, if a student writes an equation which is f is equals to m squared a. So if a student writes this particular equation, then definitely this equation is going to, we need to check whether it's correct. To check whether the equation is correct, we're going to say the units for force is mass times acceleration. Yeah, so this is going to be mass times acceleration. We know force is mass times acceleration, and this is m squared a. So if we write the unit for this is kilogram multiplied to m over second squared, mass acceleration is going to be m over s squared, and then we shall say this is mass is kilogram squared, then the units for this is mass meter per second squared, meters per second squared. But you can see now from here this equation is wrong, because this section of the equation is having different base units. So it means that this formula that we're given here is wrong. For instance, if an equation was written v squared is equals to u plus 2as, we are checking whether this equation is homogeneous or not. Then you are going to substitute the equations or the formulas there. We're going to write the units in this case, and this is going, the unit for speed, velocity, final velocity is going to be meter per second. But since this equation is squared, we are going to square that, right? And here we are going to have unit for initial velocity is just meter per second, like that, plus the units here. 2 has no units. 2 is a dimensionless constant here, so which means we are not going to consider its effect at this given point. So we are going to say unit for acceleration is meter per second square, and the units for displacement, s is distance, displacement is meters. So you end up having here as this is going to become meter square over second square is equals to, this is meter per second, and this is meter square plus meter square over second square. So you can see these units are not the same. This is meter square per second squared, and this is meter per second, this is meter square per second square. So meaning that these units are not the same throughout the formula. So this equation that was written here is non-homogeneous. And when the equation is non-homogeneous, it's a confirmation that this equation is wrong. The student might have written the equation wrongly, then you have to check. But if the equation is homogeneous, all the SI base units of all the terms in that particular equation must be the same, and that indicates that the equation may be correct. So non-homogeneous equation is we can say is an initial stage of testing whether the equation is correct or not, or the formula is correct or not, right? Because an equation can be homogeneous but it's not correct. Then for you to confirm whether it's correct, you have to perform an experiment in the lab using different apparatus to check whether it's the equation is valid. Yeah, but non-homogeneous equations, so you find one of the terms is not having the same units as the rest, then that is a confirmation that that particular equation is basically wrong. Then now let me just show you an example. Frequency f of a vibration of mass m is supported by a spring with spring constant k, and is given by this equation that we have here. F is equals to cm raised to power p, k raised to power q, and then we are supposed to find the value of p and q. So that is what we are given, and then we are supposed to work out that particular part. So at this given point, I want us to basically try to figure out how do you find a question like this in the event that you are given a question and then you are supposed to work it out. Now, the first thing that we need to find is the unit for frequency. We know that frequency is 1 over t, which is 1 over time. So which means that the unit for this is going to be 1 over a second, and the units is going to be negative s negative 1. Then also we need to understand that this has no unit, so it's not going to contribute to the mass. It's not going to contribute to the units of this equation. So we are going to have mass is the unit for m is representing mass, so we are going to say the units for m power p is going to be kg power p, yeah, because mass is kilogram, and that unit is m is raised to power p, so if we are going to have kg raised to power p. And then we have k is a spring constant. So if k is a spring constant, it will mean that spring constant is usually force divided by extension, isn't it? Force divided by extension. So which means that force is actually mass times acceleration, we know that, over extension in this case. But the unit for mass is going to be kilogram, and the unit for acceleration in this case is going to be what? Meter per second square, yeah, divide by extension, and extension is what? Meters in that case. So which means that at this point of time we can multiply by s squared at the denominator, so that s and this s squared and this s will cancel out, and then we're going to have our equation reducing to, of course, m and m will cancel out. Our equation is going to reduce to kg per second square. That is the units for spring constant, yeah. So if we combine those units here, we are going to have, let me just write 1 over a second, because the units for this is s raised to power negative 1 for frequency, but I can write it as s raised to 1 over a second is equals to, c is a constant, has no unit, so it's a dimensionless constant, it has no unit. Then we are going to say only the unit of m are going to contribute to that, but the mp, we got them here, we said is going to be what? Kg raised to power p, isn't it? And then the units for this part is going to be kg over second square raised to power q, Okay, so what are we going to do in order to have our equation have this kind of the unit? We remain with 1 over a second. What are we going to have in this case in order to remain with 1 over a second? Just figure out, what are we going to do? then it means this equation that we have here, yeah, for it to be remaining like that, it will mean that this must be raised to a half, and this must be raised to a half, yeah. This must be raised to negative a half, and this has to be raised to power a half. Yes, so this must be raised to power a half negative, and this must be positive, so that we shall have 1 over a second is equals to kg raised to power negative a half, and this other part should be kg raised to power over s squared raised to power a half. You see, a half, and this is going to give us 1, and this is going to be kg. Let me just show you how it's going to reduce nicely. We are going to have 1 over a second is equals to, I've just selected this numbers nicely in such a way, in a wise way, so that we can be able to remain with 1 over a second. So you can see this is going to be kg raised to power negative a half multiplied to kg raised to a half over second square raised to power a half, because if you are having this power a half is going also to affect the number at the denominator. Then you can see, if you are going to add the powers, the all of this thing is going to cancel out, and also a half and a half will cancel out. You will end up having 1 over s is equals to 1 over what? 1 over a second. Therefore, we can now agree and say p should be equals to a half, and p should be equal to negative a half, and q should be equal to a half, for us to have this reducing to an equation that is quite interesting. So what I need to do is just to show you the screen so that we can be able to confirm, is that true? Do we have such an option? Then if we look at this option that we are having at this point, we are having p. I've selected the option p should be negative a half, and the q should be a half. So our option should be what? Should be B. So our option should be B. So B should be our best option in that case, and that is exactly what I'm trying to say. So in that case, whenever you're going to be given questions that require you to perform questions that look like this, you'll be in a position to work them out. So homogeneous equations and non-homogeneous equations determines whether the formula is correct or not. For homogeneous equation, they just give you a picture that the equation may be correct, but it's not a confirmation that the equation is correct. Non-homogeneous equation, they confirm that equation is wrong, it's not correct. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. You can also subscribe to ProfLearn so that anytime I'm going to upload the PDF of these papers that you can see here, you'll be in a position to download them. See you in the next tutorial.